Hello everyone, I am Suchita Moril. Welcome you all in the video lecture on the topic method of variation of parameters for finding particular integral. Learning objectives of this video. Student can understand the concept of higher order differential equation with constant coefficient and they can solve the problems of second order differential equation with constant coefficient by applying method of variation of parameters for finding particular integral. Types of linear differential equation mainly divided into two parts. First is first order differential equation and second is higher order differential equation. Now, for example, first order differential equation is given by dy by dx plus py equal to q, where here the term dy by dx, therefore this is first order differential equation. Higher order differential equation is, this is the generalized form of higher order differential equation of order n, because here nth order derivative term highest power is n, and this nth derivative term is in this equation, and a naught, a1, a2 up to an, which are the constant values. Higher order differential equation mainly divided into two parts. Higher order differential equation with constant coefficient and second is higher order differential equation with variable coefficient. The example of higher order differential equation with constant coefficient, here a naught, a1, a2, a3, which are the constant values, and here derivative term is there dy by dx, d2y by dx cube or dx square, and d cube y by dx cube. And here in differential equation with variable coefficient, with these constant values there is independent variable x cube, a naught x cube, then a1 x square, a2 x. Therefore we call this as higher order differential equation with variable coefficient. Ordinary differential equation mainly divided into two parts, linear and nonlinear. Linear differential equation divided into two parts, first order and higher order. Then higher order differential equation with constant coefficient and with variable. And for this constant coefficient, for second order differential equation, we apply method of variation of parameters for finding particular integral. Now, linear differential equation, we consider here second order differential equation d2y by dx square plus a1 dy by dx plus a2y equal to phi of x. Now here we write down this equation in symbolic form by substituting d by dx equal to capital D. Therefore, and this bracket is completely f of d term of y equal to phi of x. Now, solution of this equation is given by y equal to CF plus PI, where CF means complementary function and PI means particular integral. Now here we have to find out complementary function by using this method. These are the steps. First step, write down the given equation in symbolic form. Then put d equal to m in this f of d of y equal to 0. We call this as auxiliary equation. And we solve this auxiliary equation and find out the roots of the equation. Depend upon the nature of the roots, we write down the CF. Here we consider second order differential equation, therefore m equal to m1 and m2. Consider case 1, roots are real and different, therefore CF is given by C1 e to the power m1x plus C2 e to the power m2x. Here we have to substitute m1 and m2 value. Case 2, roots are real and equal, that means m equal to m1 equal to m2. In that case, CF is e to the power mx into c1 plus xc2. Here we substitute the value of m, which are the equal values m1 and m2. Now case 3, whenever the roots are imaginary in the form of alpha plus minus I beta, where alpha and beta are real, then CF is given by e to the power alpha x into c1 cos beta x plus c2 sin beta x. Here we substitute the value of alpha, which is the real part, and here cos beta x and sin beta x term, that means we substitute the value of beta. In this way we find out the CF. Now particular integral, This variation of parameters for finding particular integral is applicable only for second order differential equation. Therefore, we consider second order differential equation. Here, CF is C1 Y1 plus C2 Y2, where C1 and C2 are the constant values and Y1 and Y2 are the functions of X. Then, Pi equal to Uy1 plus Vy2, and where u equal to this integration minus y2 pi of x, y minus y2 y2 is known from CF, and phi of x means the right hand side of the equation 1, and denominator term is from y1 and y2 terms, that means y1 y2 dash minus y1 dash into y2 into dx term, where v equal to integration y1 pi of x upon y1 y2 dash minus y1 dash y2 into dx, where if we observe the terms, denominator term of u and v are same. Therefore, we have to find out denominator term first and then find out u and v values and substitute these u and v values in equation 3 and write down the required pi, and lastly write down complete solution y equal to CA plus pi. Now we discuss problem on this. Solve by method of variation of parameter d square minus 6d plus 9y equal to e to the power 3x upon x square. Now consider the given equation gives equation number 1, which is second order differential equation with constant coefficient, and we find out its solution by finding CF and PI. Therefore, CF means complementary function, PI means particular integral. Now, for CF, we apply the method. We write down the auxiliary equation by substituting d equal to m. Therefore, m square minus 6m plus 9, its value equal to 0. Now, we solve this equation, find out the roots of this equation, total 2 roots, m equal to 3, 3. The roots are real and equal. Therefore, we apply case number 2 and write down the CF value C1 plus XC2 into e to the power 3x. Now we separate the terms because we have to write down CF as C1 Y1 plus C2 Y2. Therefore, we multiply the terms here C1 e to the power 3x plus C2 x e to the power 3x and write down the value of y1 and y2. C1 y1 plus C2 y2. That means value of y1 is e to the power 3x and y2 is x e to the power 3x term. In this way, we write down y1 and y2 and we use this y1 and y2 value for finding pi by method of variation of parameter. Therefore, by using the method of variation of parameters, here pi equal to uy1 plus vy2. For this u equal to equation number 4, this is the formula, and v equal to equation number 5, which is the formula. We apply this formula and find out the required values of u and v. Now here denominator term of this u and v are same, therefore first we find out the denominator term value y1 y2 dash minus y1 dash y2. Now here substitute the value of y1 e to the power 3x and y2 value is x e to the power 3x. Now here we find out its derivative by applying product rule. Here x as it is, derivative of e to the power 3x is 3 e to the power 3x plus in second term here e to the power 3x as it is and derivative of x is 1. Now for second term minus sign as it is y1 dash. Now first y1 is e to the power 3x. Therefore derivative of this term is 3 e to the power 3x and second term y2 x e to the power x as it is. Now we simplify these terms here. These 3x e to the power 6x and these 3x e to the power 6x. This value is negative and this value is positive. Get cancelled. We get e to the power 6x term. Now we calculate u value by applying the formula 4. Therefore, u equal to here substitute the value of y2 minus of y2. This is the right hand side of the given equation e to the power 3x upon x square and denominator term is e to the power 6x. Now we simplify this in numerator here e to the power 3x into e to the power 3x. This value equal to e to the power 6x upon x, because this xx get cancelled, and denominator term e to the power 6x. Now this e to the power 6x and this term e to the power 6x get cancelled. We get minus integration 1 by x dx. On integrating, we get the value u equal to minus log of x. Use equation number p. Now similarly, we have to find out the value of v by using the equation number 5. Therefore, we substitute the value of in the equation 5, and v equal to here y1, then this is the right hand side of the equation, then denominator term. Here e to the power 3x and e to the power 3x, that means e to the power 6x term upon x square upon denominator term e to the power 6x. This e to the power 6x and in this e to the power 6x get cancelled. We get integration 1 by x square dx and its value equal to minus 1 by x, which is the value of v. Use equation number C. Now we write down pi equal to uy1 plus vy2. Here substitute the value of u, then y1 plus v into y2. And if we simplify this, x get cancelled, we write down this equation as d. And lastly, write down complete solution y equal to ca plus pi and substitute the values of equation number a and d. Then we get the required result. In this way, we solve the problems of method of variation of parameters. Thank you.